Okay. So, hopefully in the second half, we will have time to quickly move to what I actually want to talk about. And I hope that by now you at least got like an overview idea about what is a blockchain or what is Bitcoin. And to sum up the first part, we can simply define a blockchain if anyone asks you what a blockchain is. A blockchain is nothing but a distributed secure log file. So it's kind of a database that contains some knowledge, some information about some transactions that define the state of a certain system, that here in Bitcoin is a monetary system that manages the transactions of exchanging money, and that is also managed and maintained in a decentralized way. Okay? So there are two portions in defining a blockchain. The first one is the data storage part, which is like this immutable log. And I don't know if you got the hint from where the immutability comes from. When we said that we are using this hash pointer, so I'm always pointing to my child and hashing my parent, okay? And then my child will point to my grandchild and will hash myself. When it goes like that, when the chain grows, then the longer the chain gets, the more difficult it is to change content in the older blocks. Because if you want to change now content in a block number 1, you need to change the content in all the blocks that follow, right? So this is from where the immutability comes from. Well, actually, it's not purely immutable, but practically it's quite costly. So there is no one who will go and bother with paying the cost of changing information. Instead, they have the incentive, especially in the context of Bitcoin, to keep extending and increasing the chain because there is monetary benefit in there, okay? So we said a blockchain, it's two things. It's first this immutable log for which the immutability is assured by the hash pointers. And it's also, it has a second component, which is a given protocol that now allows the management of the chain in terms of writings. Who will be writing to the chain and how the writes to the chain will happen. You had a question, maybe? I'm sorry? How fault tolerant it is. Okay, yeah, we'll get into that because this is one of the very important things. It's also the security of the system. So is it clear now just so far what a blockchain is? So a blockchain could be actually seen as a little bit perpendicular to the usage of bitcoins or monetary systems. So any system that can use these blockchains for like this concept of this decentralized ledger with a corresponding decentralized protocol for managing the rights to the ledger could be considered as a blockchain as well. Okay? Okay, so this is just like to represent this idea that in terms of the security of the system, since we are in a decentralized setting, it might happen that some of us will have different versions of the same log. So for example, some of us will have this block 1, 2, 3 until 10. Others will have the idea of 1, 4, 7 because the system is asynchronous, and maybe we are not all hearing about the same updates at the same time. So at different times, we might be having different versions of what the log or the state of the system is. But then again, this is solved by a simple little convention. We will just say that the convention says the longest chain is the one that holds. Okay? So whenever you hear from other peers about another chain that is longer than the view that you have, you will drop the short one that you have, and you will adopt the longer one. Okay, so I will skip here this what is Bitcoin, but just one thing here that I need to highlight is the one that I have in green, because maybe up to now I didn't say specifically this word proof of work. So this thing, this brute force of trying to find these hashes, these R's that will hash to and solve these puzzles, since they are kind of brute forcing and using your hardware just randomly to try to find the solution, it's called proof of work. So proof of work is nothing but that simple algorithm that is but keeping randomizing. So the algorithm will go while true, do what? Randomize R, hash R and B. If it is smaller than D, terminate and announce the block. Okay? So this is as simple as what proof of work is. Now, there is, the blockchain is not only Bitcoin per se. There are so many other maybe blockchains, altcoins, if you have heard about this term as well, alt for alternative coins. So it's just other people or other communities trying to imitate the same idea that originated with Bitcoin and trying to do it in broader application domains. So you can see, for example, that there is this Zero coins, there is Ethereum, there is Namecoin, there is Blockstack. There are so many initiatives trying to adopt the same concept to try to allow for blockchains in different areas. So just these are some of the few examples that I found. And actually, maybe if we just think about it a little bit further, we can find that any system in which we need to prove the existence of something in a decentralized way, in which we don't have maybe a central authority that we can trust, or in which we don't want to trust a single trusted authority, we can just apply it to blockchains and solve it. But then, of course, there are so many other issues that we will need to handle that are not mostly technical or technological, but that are, again, just managerial. Like if we want to apply now a blockchain to something that is not monetary, what will be the incentive for people to keep mining in proof of work then? Okay? Okay. So you asked about how this is fault tolerant, right? And I have here some few slides to explain why proof of work and why Bitcoin works. Now from a security perspective, why the system is secure, why, and what are the things that, the guarantees that proof of work provide to us. So to explain that, I thought that let's take an example that is a little bit outside of Bitcoins to see that these things can also be applied to other application domains different from managing digital currency. So now assume that we want to establish a new system. We will call it master degree chain or M degree chain, which is nothing but a log or a ledger in which we will be now logging all the master degrees that people around the world will be achieving. Okay? So whenever a university, like whenever someone graduates from a university, instead of the university giving you the specific, like the physical diploma, they will just announce in the chain that this student has graduated with that specific master and then have it there in the chain. And you can prove wherever you go that you are actually a graduate from that university because your information is there in the chain and will always remain in the chain. Okay? So let's just try to analyze quickly what could be the pitfalls or the security issues or the risks to such a chain. The first one, since this is again kind of decentralized and trustless and we don't trust any central entity, what about fake master degrees? Like anyone, maybe you can imagine that anyone can come up and say, okay, I graduated from Harvard, and making such an announcement, and then if that person convinces the community managing this M degree chain, then his degree will be there. Now, if other employers trust the information in the chain, we'll see that this person has graduated from Harvard, whereas this person maybe has never been ever there. Okay? So, how this, can you have any hint about how this is solved actually in chains? Okay. The security of the specific kind of attack is ensured by the underlying cryptographic scheme. So again, this is a little bit outside of the concept of a blockchain in itself. So it comes from cryptographic measures or from cryptographic guarantees. We assume here that every university has or is known by a unique pair of a secret key and public key. And whenever the university signs something with its secret key, then we trust that it comes from it. Now you might say, what if someone steals the key of the university? This is outside of the system. This is quite orthogonal to the system, and it's exactly equivalent to someone having access to the amenities of the university and maybe stealing the stamp of the rector or something and faking a diploma. Okay? But this is outside of the system. And the security of this faking things, or even faking money in terms of Bitcoin or whatever other application domain you can think of, here it still shows that cryptography is still needed in the system somehow, because we are in this decentralized setting and there is no centralized entity that certifies information. So the certification of information relies on public key cryptography. Clear? Okay. Then there is another another problem that maybe we have also discussed briefly right before stopping for the break, when we said for Bitcoin, once we stop creating the coins, what will be the incentive for people to mine? And we said that there are these tips, but if you give a small tip, maybe you might end up being denied service. Now, what if it is not willingly just because your tip is small, but because intentionally some miner or some member of the blockchain management community wants to deny you service to a specific user? So in our example here, assume that we have a certain Bob who actually graduated from Yale University, and the university submits his graduation, oh, there is a typo there, his graduation transaction to our chain. But there is a certain person, like a malicious element in our community, the community managing the blockchain, who has some personal issue with this Bob and who doesn't want this information to appear in the chain. So even without showing to the rest of the world or to the rest of the community that she is malicious, she can still keep doing all the things right, only providing valid graduation transactions, doing valid mining if you are doing mining, but at the same time always keeps dropping this transaction. So whenever she hears about the transaction of Bob graduating from Yale, she doesn't include it in any block of transactions, and she doesn't broadcast it further to the other members of the community. Okay? Now, why this, again, this risk exists in Bitcoin as well. Like someone passing a transaction and the miners just keep dropping it for a reason or another. The premise behind this is that even if we have one or some members or miners of the community that will engage in such kind, between brackets, malicious behavior, there would be some other honest people that eventually will hear about this transaction and will include it in the blocks that they generate. Okay? And from here comes again why we needed since the beginning a random process for selecting different people who will be committing new blocks. It's exactly to guarantee that it's not the same people that will be selected over and over again to commit blocks, and there will be some other honest people that eventually in time will be selected. So from here comes, if you've ever heard that Bitcoin or blockchains are secure or can tolerate up to 50% of malicious nodes or peers. So if we have at least a 50% plus of honest nodes, it means that there is a 50% probability, or that every one time, like once maybe a malicious node will be selected and will not include this transaction in their blocks, but in the next time, an honest node will be selected because we have a 50% honest majority, and then the transaction will end up being displayed in the chain. Maybe just a bit delayed, but we assume that we tolerate delay in time. Okay? Yes?
Why the number of 50%? Like, could be like, I don't know, 90, and you want to keep 10 times until you find a node that actually possesses your transaction?
Yes, but well, it's actually just, again here, we can be still secure even if we have, it depends on how you formulate your notion of being secure. Yes. It's not arbitrary, actually. It's just like saying, if there is more than 50% of like malicious nodes, then they are kind of dominating. The more you increase this probability, the more they dominate the network. And the less the probability for an honest node to be selected to make something good is, right? And then you will end up having maybe this long chain just full of rubbish, of malicious content. And then the honest content also will just kind of be poisoned inside, even when this node is selected. Oh, sorry.
So maybe the tag is 50%. If you have less than 50, you would not be able to create the longest chain.
Yes. Well, or maybe it will. You will have a long chain, but it will be a fake long chain.
Yeah, but wouldn't be the longest, because the rest, if you have less than 50% of overall power, it will be harder for you to create the longest. Otherwise,
Yes, yes.
You can ignore the rest. If you say you have more than 50%, then if our agreement is that the longest chain wins,
Yes.
the incentive is to take the longest chain, then I wouldn't care about the rest anymore. I have more than 50%, I create whichever chain I want.
Exactly. Well, yeah, it's exactly that. The thing is that if you have more than 50% honest nodes, then the longest chain will be the honest chain. But if you have more than 50% malicious nodes, then the longest chain will be the malicious chain. So even if the honest community try to like compete with the other ones, they will have their kind of good chain that is not malicious, but it will be the short one that the others will not be accepting. Yeah. So we will still have this concept of long chain, but it will be a malicious long chain. Okay, now there is another thing, another aspect that is actually very to be appreciated about this concept of proof of work and mining in blockchains, and it's resistance against Sybils. How many of you have heard about this term Sybil accounts before? Okay, so maybe just a person in the room. Well, a brief definition. Sybil actually, I haven't read the book myself, but it's it's a novel book. I don't remember even who the author was, but that's the title of the novel. The novel book is Sybil, and Sybil is the name of the protagonist of the novel, and she has like kind of a psychological trouble by which every day she assumes a new personality. So she wakes up today and she thinks that she is a doctor, and the other day she thinks, I am a professor at KTH, and she goes to KTH. So she has this psychological trouble that makes her assume different personalities every time. And from here, like it was taken to refer to those nodes in systems that behind the system there is actually only one single physical person or entity, but that person is creating multiple identities that are eventually fake, because I cannot be represented as a single physical person by multiple identities. Okay? So maybe one of the things here that you can think of in terms of blockchains is that to dominate the network, since we are in a decentralized one, I will just keep creating fake miners, like create multiple accounts, and then eventually, if I have more than the others, I will dominate the network. Now, the thing here, because of this proof of work, what I'm doing when I'm creating Sybil accounts is that I am distributing also my hash power, or the power of my machine, into trying to compete to find these solutions. So the nice thing to appreciate about proof of work is its resistance to Sybil accounts. And it's built into the system. So no one, even if they are malicious, will have the interest into creating Sybil identities to poison the system, because this means that you will have multiple small, tiny accounts that will have no power into the system, that will never be selected in any round, because you just cut your power into across all the ones that you have. Okay? As a quick summary, what proof of work provides? What are the things that anything else that we will need to think about needs to provide? It's fair and verifiable decentralized leader selection. So it's a fair game, kind of. You keep try to find in the solution, and it's very easy for all of us to verify that, yes, you did hit a solution. And the second thing is that it's this Sybil defense mechanism, which means that it's not in the interest of anyone to keep creating multiple fake accounts. Okay. Now, proof of work is nice from all the perspectives that we talked about, as long as we are theoretical. From a practical perspective, it could be viewed as a dirty energy. So you can assume that we have a network of, let's say, 1,000 people, and every time it's only one person who is selected, the 999 people have been just burning energy in terms of electricity and in terms of also hardware into finding something or into doing some work that is quite useless by the end, especially if they are not selected. And I have actually, I don't know where I have, I have some statistics here. It says that, this is quite old, but it might even still apply now. In June 2015, one single Bitcoin transaction required the same amount of electricity as powering 1.57 American households for one full day. So this is only one transaction. Like me buying a chewing gum will require that we burn that much energy. So with all the advantages of proof of work, clearly it doesn't scale. Now that's just from an energy consumption perspective. But there are other perspectives as well that maybe we don't have the time to cover here, is that it creates this interest into people going and buying like these mining pools. So instead of just mining by small equipment, there are huge mining kind of data centers in which people just keep doing this business, because also there is this monetary advantage. So I think I will skip that. And I will go to this alternatives proof of work. So because of that, people have started, since when Bitcoin started being famous, people started thinking about, okay, this is a nice system, everything is beautiful and good, but we are bothered a little bit by this proof of work. Can we find alternatives that don't, especially from the perspective of just burning energy just like that uselessly? There are actually quite a number of them. I don't know if you've ever heard about these things. Like maybe whoever reads about blockchains has crossed before like proof of stake, proof of burn, proof of capacity, proof of activity, etc. So briefly, just for your general information, proof of stake is, it actually holds mostly in the monetary field, in the monetary domain, like in Bitcoin. It was suggested for Bitcoin. Now, instead of going and doing this mining, what we will do, every time when we want to add a new block, we will see who of us has the highest number of Bitcoins. So whoever can kind of prove that he or she is the richest in terms of the number of coins that they own will be selected. Okay? Now, the thing that might come to the mind very quickly is that maybe that rich person will remain rich for quite a long time, and then it will be the same person selected over and over again, and we are falling again into some pseudo-centralization. Well, the idea here is quite nice, is that we are kind of combining both wealth and the time that this wealth has survived through. So we are not only picking up the richest person, but the oldest richest person. Kind of. And once you are selected, we consider that you have spent this money. It's like you have already like made some new transactions, and so it's like it's a newly acquired wealth. So you go down the list and you wait until like again someone else comes. Yeah.
Let's say that I am the richer by far.
Mm-hmm.
I'm getting over the proof of the network, and when I'm close to the limit, I transfer all my money, which I don't pay because I get the transaction fee, to another person, which is me actually, and then I start doing it again.
Well, the idea again, it's the same. It goes when you analyze it theoretically, it goes again to the same proof of work. And in terms like we said that even in proof of work, if you own more than 50% of the mining power, then you are dominating the system. Okay? It's the same thing as proof of stake. If you are by far the richest person in the system, like by more than 50% of all the wealth in the system, then yes, you will keep, even if we consider this, it will take some time before you kind of zero all your money. I mean, it's not losing your money here in proof of stake, it's just changing its age. It's like considering that your ownings have an age. So from the moment you own this money and you haven't spent it, there is also this kind of concept as well that I forgot to mention, is that in proof of stake we consider that you have money that you haven't used for some time, for an X amount of time. Okay? Once now you are selected, for example, to mine a new block, we consider like you have used it in a transaction and the age of the money goes back to 0. So you cannot use the same coins in the next round, in the next competition. Okay? Now, proof of burn is a little bit counterintuitive. I mean, no one would go for it, but it was one of the ideas. Now, instead of just like changing the age of the money, I will just burn it. So just losing all what you have, basically. So theoretically, it could work, but practically, no one will do that. Proof of capacity, it's exactly as proof of work, but there are so many people who went into trying to find alternatives to proof of work of, instead of making use of using your processor, let's now focus on using memory, because memory is cheaper and maybe consumes less energy. So they were trying to find some hash equations or cryptographic equations that instead of requiring too much processing power, they just require huge amounts of RAM. Well, anything. There is proof of usefulness. There are some papers now suggesting that instead of having like this stupid kind of hashing and trying to find some random numbers, let's make all these miners try to solve some NP hard problems, for example. And so the power will not be useless, but it will be used to generate some value. Yeah. So I think this is actually the core, the idea is that there are so many people still thinking about alternatives to proof of work. And here I will get, yeah, sadly enough, it's the last 15 minutes, but we'll try to squeeze it. Now, in this decentralized settings, now we agreed what miners are, and we know like all these alternatives, or we have at least discussed them briefly. So we have a network of miners, and in all of them, we assume that there is no notion of trust. This is basically one of the underlying things of blockchains, is that it's a trustless system. I don't need to trust the miners or to know them. I just trust the protocol. I trust the system. I trust the proof of work. But this comes at the cost of this energy expenditure that we said. Now, let's lessen a little bit this assumption on trust and assume that we are kind of able like to come up with some trust network related to the miners, especially if we want to make use of blockchains in some application domains where there is actually trust networks, where there are trust networks. Like, for example, something like, let's say, a system that now banks across the world want to use to manage something using blockchains because no one of them wants to take the responsibility of managing it by itself, but they still want to all collaborate. Still, there are like transactions happening between them, so we can infer some kind of relationships or trust relationships between the different nodes there in the system. Or, for example, we can go to social networks. So there is exchange, there are interactions, there are relationships between people. So there is an underlying trust network there as well that we can infer from. So the idea was that now, assuming that we have this trust network that we can encode as well inside the blockchain, because we don't want to give up on our decentralized or peer-to-peer kind of conception. What about instead of selecting like the richest person or the person who has like the finest hardware or the largest hardware to solve these proof of works, what about picking up the most trusted person in the network? So the idea is as simple as that. It's just going for something called proof of trust. So you need to be trusted. You need to prove that you are trusted. But it's simple, but it has some challenges. So let's first see this very simplistic process that represents kind of the big idea. So we have a chain. We select the most trusted person somehow by some proof of trust algorithm. That person extends the chain, which means adds the new block now in the chain, and then goes on, assumes some other responsibilities. Here is some proof of trust algorithm to find the next trusted node. And I will update all the trust ranks of all the existing nodes in the network. We will see how this happens. And then we'll announce the next leader or the next highly trusted node. Then that highly trusted node will again suggest the new block, and we'll do the process again and again, and it goes like that. Now, what is the issue with that? Okay. Yes, we first need something to select this most highly trusted peer, right? But remember, there are things that proof of work assured to us, and these were Sybil resistance, and there was only this eventuality that anyone has the probability or has a certain probability to be selected, okay? So maybe one of the easiest things that we can think of when thinking about trust, and maybe it's one of the algorithms that you've also have been through in this class, is, say, page rank. So we have a trust network, which means we have like some nodes linking to others, trusting others, okay? So maybe one simple idea is to say, okay, let's run PageRank, and the node with the highest rank will be the one to be selected. How does it sound?
But this is only get the most connected nodes, right?
Yes, well, the most connected.
Trustful.
Well, here if we go, it depends on how you consider the underlying network. Assume that the underlying network is not a connection network, is a trust network. So my edge there going from H to B means that H trusts B. Doesn't mean that it's only connected, okay? We're already starting from the assumption that we are having a trust network. So it means that the node that has the highest page rank, if we just run a simple page rank algorithm on this kind of network of trust, will be the highly trusted one, right? It's the one getting most of the trust from the network.
But, I mean, we started with a graph that there is this cluster problem, and there are some nodes that have more trust than the others. Like there is, like in a group of 50 people, there is one which has the trust of all of them, and probably this person is linked with another person with 50 friends, etc. So, and I can assume that these people know each other because usually are influencers in the Bitcoin or blockchain environment. So, if they want at some point do whatever they want, they can just do it. Let's say that tomorrow they want to fork it and give it your blockchain for another one. All the others are screwed up because they don't have anyone to trust.
Yeah, well, that's a valid point in terms from a security analysis, but then it goes from the fact that these people, they got there because they were trusted by the others.
Yeah, but I mean, for example, what happened there was true position, like the one that has the Bitcoin that wants to keep the Bitcoin, so they don't want Bitcoin Cash, and these were the trustworthy nodes. So, I mean, that's what I'm saying.
Okay, what you are saying is very valid. I will take it one step back, even before getting to that level. There are issues with this. I mean, it's very simplistic. Let's take any algorithm, for example, PageRank, and run it and get the highly trusted node and say, okay, this is the node that will now start or that will make the new transactions. But don't you see any problem with that?
It's not Sybil proof.
It's not?
Sybil proof, right? You can have several nodes. You can create several nodes yourself and point to yourself.
Okay, so it doesn't give Sybil resistance, doesn't it?
If you create several nodes
Mm-hmm.
and point to yourself.
Okay. But they need, is it enough that they point to yourself, like create different nodes? How does it work in PageRank? Now, assume that we are in a centralized setting. Forgot about decentralization. Assume that we are like having all the idea about the graph, we are having all the nodes, and then suddenly there is someone who is creating this Sybil identity or creating a node and making many other nodes point to it.
The other point is that if I'm the only one,
Is it enough that they point to it?
no, because I don't have reputation. Like my link to your node has low reputation,
Exactly.
but I can link themselves.
Because here in my network, there is something here that I had actually to represent it. These guys are connected as well. So the thing or the idea, the nice thing about PageRank maybe that I also wanted here that we get to, because I wanted to go through this analysis, why it does give this kind of similar Sybil resistance as what is existent like in proof of work, is that it's not in my interest to cut my node into several nodes and just keep pointing to it with like zero balanced other nodes. So if I want this to fall into this node to which I want like, or of which I want to increase the trust, I need to have these ones like also have some incoming flow, right?
I have a more question. How do you handle the direction of the edges? Because here is in PageRank is unidirectional,
Yes,
but you need bidirectional here.
yes.
So how do you handle that?
Well, we just,
You don't know who is pointing to whom.
no, we assume that we have an underlying trust network in which, yes, yeah, in which like it's kind of directional. Like I know that B is trusting D and D is trusting C.
And another thing, like I can point my sibling networks to each other, and this gains kind of trust. Or I mean, the way you define the reputation of each node, how do you do that? Because in a page, in a web page, there are people that are reading it, so the more people are reading it, or etc., the more interacting and creating. But here is everything strategy proposed. So
Yeah.
do you take some kind of cluster? So if the link are inside, like, okay, let's say that the link are friend of a friend, so it was like cluster coefficient,
Mm-hmm.
then you give a small power to them. Do you do something like this?
No, what we do actually, I will get to what we do, but before, because I have this also like a bit in some couple of slides after that, what I wanted first to set here are two main things. First is this fairness and verifiability and Sybil resistance. And we have discussed Sybil resistance, and I don't know if it is quite clear to all of you here how the choice of PageRank will at least give us some kind of guarantees against Sybils. And we will see that a bit further. We can discuss it further. But there is another issue that we need to care about. Maybe that any one of you would hear or could have thought of since the beginning. We want to ensure that there is fairness or there is eventuality that anyone in the system could eventually be selected to participate in the game, okay? Whereas in trust networks, things are quite stable. So at a certain time, maybe we will converge, and the highly trusted node will be the highly trusted node. It's something like proof of stake, like the richest will be the richest. Don't you see any problem there? It will be kind of centralized. Like if we are in this kind of network that I'm given here, once we converge to this situation, then this B is the giant one that will always keep being selected. So it's the mostly trusted node, okay, fine, but it's then always the mostly trusted. And we need huge changes to happen in the network before this thing changes and any of the other nodes in the network gets a chance, right? And this is one of the things that we actually don't want to do or don't want to have. So what are some other things that we can think of to go around that? Any idea? Yes?
We select the nodes based on the rank with the probability. So if someone with the higher trust gets a higher chance to be selected, but others with lower trust can get selected.
Great. Yeah, we can do that. We can even manage this or integrate this notion of randomness, kind of, or of increasing probability with some proof of work. So maybe we will not give up proof of work at all, like at once, but we will say, okay, the more trusted you are, the less work you have to do. So you still will have to solve these hash puzzles, but if you are a highly trusted node, we will just increase the range for you. So we are making the game easier for you. If you are a new node that has just joined and that still wants to get a chance in the system, we will just make it a little bit more difficult for you, but eventually you will have a chance to be selected for a round. Right? Okay. So actually there are several strategies for that. Yeah. Well, what I have here, I forgot the order of my slides, is that I wanted to say that these things happen, and they do actually, because when we went to the analysis of real trust networks that we got from real data sets and real graphs, what we found is that the highly trusted nodes remain highly trusted, like for quite a long of time, or after the network converges, it's only like there are slight changes happening, but they keep like again, appearing again and again. So for example, here I had 4 nodes that for the, like starting from, these times are not time 0, but let's say starting from like a specific time when the graph started to converge and to stabilize, they kept reappearing. And maybe you can see it here even clearly, more clear. So in the table here, I'm just showing the top nodes in terms of the highest rank that they had. And here, the time is not the time, it's just like the iterations. So at the beginning, for example, node number 8, it was the leader for the 2 first iterations and then the second leader in the third one. And then the one in green, for example, it kept appearing. The one in yellow started appearing from the 3rd iteration, and then it kind of kept surviving until the 5th. Yes?
How do you draw the network?
I
suppose you have to make a transaction for that.
No, well, these are just analyzing like real trust networks. It's a real data set that already has the trusts.
In your system, in the page rank system, how do I know the structure of, okay, we can talk about it later. I know, watching the clock.
Yeah. Well, just quickly, so maybe so that it's clearer to the others as well. These are like, we are running the proof of trust or making these computations of rank based on an existing kind of trust graph or trust network, okay, for which the information is already encoded in the blockchain.
Yeah, but let's say that this is a group of nodes that has some link, but it's not linked to you,
Mm-hmm.
only linked to me.
Mm-hmm.
Why should I say to you that they're all linked and they have a high page rank and not say to you that
Okay, so the assumption here is that anyone who is like pointing to someone announces this. So I'm not announcing the ones who are coming to me or who are trusting me. I'm announcing the ones whom I trust. So every node makes announcements about, they are considered also as transactions. And the transaction is a trust transaction saying that me, I'm trusting you. Yes, yeah. And so it's in the interest of anyone to say that I trust someone, because if I trust you, I hope to get something back from you. Yeah, that's also a valid point. So just to go back to this thing that we started discussing about is that we want to give others a chance as well, even when this thing like converges and we keep getting like these highly trusted nodes getting repeated over like different iterations. So one of the most naive ideas is maybe to make some round robin among the n top most trusted nodes. Like for example, it's similar to the idea of proof of stake. If you are now selected, even if you are the highly trusted or the one with the highest rank, you will not be selected for time T2. You will wait until some time and then you will be selected again, okay? Now there is another idea. What about, for example, just ignoring all the links that go to this or that are given by this highly trusted node? Like once you are like this B, this big one, this giant one, you are selected, you made a commitment, you made a new block. Now we want to give the chance to the others. What about just cutting this one from the network? What will be the implications on doing such a thing?
the link or
Yes.
the rank?
Yeah, no, the links.
I mean, how do I set up the
think in terms of how PageRank is working.
Also the others.
The others will be affected as well. So I'm not only penalizing that specific node, but I'm also penalizing all the ones to which it is given out of its trust as well. Okay? So it's not as straightforward as just saying we will be ignoring. So what we could do actually is to freeze the rank. Now, instead of just removing it or cutting it, we can freeze it. So it's still given of its kind of its mass to the others that are linked to it, but it's frozen. For its status is frozen and cannot be selected, yes.
How I choose if a node is trustable? I mean, it's something that each node has to, like each account, each engine that set up the node has to do manually, or is it automated? How does it work?
It is, yeah, okay. So the computation actually of proof of trust or of PageRank is centralized per node. So every node, we have all the information encoded about the trust network in the blockchain, so anyone can just get the information and make the computation locally. You got the idea?
Not a real trust, I mean, it's a trust based on data.
Yes.
Which data?
Yes.
Which data?
It's the data that is kind of uploaded by people saying that I trust this node, and it's already committed to the blockchain and verified by signatures.
In the day zero, when I start, I have a graph fully connected.
It could be fully connected. It could be just like composing itself or starting. We don't care about that. Like even if we have a partially connected, like not even partially connected, we have some nodes that are not connected, maybe we can bootstrap in. This is bootstrapping the system. We can bootstrap it by pure proof of work, for example.
But if you have very few